Hello viewers, this is Wagda Ronald taking you through today's tutorial on differentiation 1, and in today's lesson will be on derivatives of polynomials. So derivative of a polynomial is the sum of the separate derivatives of the terms, and this rule applies only to functions that can be expressed in form of a polynomial. In other words, functions like square root of 2x plus 3 or quotients like 3x plus 4 over x minus 1 cannot be differentiated using this formula you're going to see. So in lesson 1 we saw that if I want to differentiate x to the power n, the answer will be n times x power n minus 1, and if I want to differentiate a constant, the answer will be 0. So we shall use that to go through the solution, the following problems. So problem 1 was they want us to differentiate the following with respect to x. Roman 1 x squared in brackets 4x minus 2. Roman 2 in brackets of x plus 1 multiplied by the brackets of x plus 2. And Roman 3 bracket of x 2x plus 5 squared. So here what you should note is that we have to express the given function as a polynomial first by expansion. After converting it into a polynomial, you can then differentiate term by term. So y, for example, Roman 1 y was x squared in brackets 4x minus 2. So in this case we have to first open brackets to get 4x cubed minus 2x squared. From there we can now differentiate this. This will be 3 times 4, which will give you 12, times x to the power this but with the power reduced by 1. So 3 minus 1 you get 2, that is the new power, 3 minus 1, minus, now 2 times 2 will give you 4, then when you reduce the power by 1 you will get power 1, which is the same as x. Therefore the result will be 12x squared minus 4x, and that will be our answer. Roman 2 we were given that x plus 1 in brackets, then multiply by the brackets of x plus 2. Here you have to first open brackets. This times this will be x squared, this and that will be 2x, and this will be x, this and that will be 2. Or that we shall correct like terms. I think I can say that 2x plus x you can get 3x. So now you are going to differentiate this. Differentiating x squared, bring down the power to become 2x. Differentiate 3x you get 3. Differentiate 2 you get 0. So the result will be 2x plus 3. Roman 3 they wanted to differentiate 2x plus 5, everything squared. In this case we shall first expand. So this squared will give you 4x squared, 2 times this times that will give you 20x, plus this squared to give you 25. Now this is already a polynomial, now we can differentiate. So differentiating 4x squared will give you 8x, differentiating 20x will give you 20, differentiating 25 will give you 0. Remember 25 is a constant, so when differentiated you get 0. So the answer will be 8x plus 20. That has been the solution to problem 1. Now we shall go to problem 2. Problem 2 they want to differentiate the following with respect to x. Roman 1 2x cubed minus x squared, everything divided by 3x. Roman 2 x cubed minus 2x squared plus x minus 3, everything divided by x. Roman 3 x plus 2 in brackets multiplied by the brackets of 1 minus 2x, everything divided by x squared. I think I can see that this one is not the same as this expression. Why? Because here in the denominator there are 2 terms, x minus 1. So when there are 2 terms or more, when it's more than 1 term, they cannot be transformed into a polynomial. So for the given question, these ones can be transformed into a polynomial because denominator is only one term. I think I notice that it is just 3x here, x here, and x squared here. If for example if they say 3x plus 1, then it would be impossible to transform it into a polynomial. So we shall now go to the solution. First of all, you have to first express it in form of a polynomial by dividing each numerator by the term in the denominator. So here we shall let y to be equal to this. This was the expression given in Roman 1. So we shall first split the numerator by dividing this by that, and also this by that. So this by this will give you this, this by this will give you that. So here I shall use the rules of indices. It will same base, subtract the power, so it will be 3 minus 1 to give you 2. Therefore the result will be 2 over 3 x squared. For this one, same base, subtract the powers, it will be 2 minus 1 to give you 1. So the result will be x over 3. Now I'm going to differentiate this because it's already in form of a polynomial. So for this one, bring down the power, it will be 2 times 2 x to power 1, which is that over 3. For this one to be differentiating x, I'll get 1, so it will be 1 over 3. So when I simplify this, I'll get 4x over 3 minus 1 over 3. Same denominator, we can put it everything under one LCM to become 4x minus 1 over 3. So that is the answer for Roman 1. Roman 2, we are given this expression, so we shall still do the same. We have to split the numerator, so it will be this over that to give you this, this over this to give you that, this over this to give you that, and this over this to give you that. After that, you shall apply the rules of indices. This over this will give you x squared, this over that will give you 2x, and this will give you 1, this will give you 3x power negative 1. Now it's in form of polynomial, so you can differentiate. So differentiating x squared will give you 2x, differentiating 2x will give you 2, differentiating 1 will give you 0. Remember, 1 is a constant. Then differentiating this, we have to first bring down the power to become negative 1 times negative 3 to give you positive 1 times 3. Then here reduce the power by 1, so it will be negative 1 minus 1 to give you negative 2 as the power. So now we can simplify. Negative 2 and 1 will give you negative 1, then 2x, so the answer will be 2x minus 1 plus 3x power negative 2. Then Roman 3, we are given this expression. You have to first expand the numerator to give you that. After expanding the numerator, we shall now split the numerator. So here we have corrected like terms. This 4x and this one will give you negative 3x. The rest remain the same. Now we shall split the numerator, this and that to give you that, this and this to give you this, and this to give you that. Then from there we apply the rules of indices. This cancels, to remain with negative 2. For this one it will be 2x power negative 2, and for this one it will be 3x power negative 1. So we shall now differentiate. So this is a constant, negative 2 is a constant, so when you differentiate it you get 0. Then for this one, bring down the power, it will be negative 2 times 2, which is negative 2 times 2. Then reduce the power by 1, so negative 2 minus 1 will get negative 3, which is there. For this one, bring down the power, so negative 1 times negative 3, you get positive 1 times 3. Then reduce the power by 1, you get, it will be negative 1 minus 1 to give you negative 2, which is that. Then you can simplify. This will give you negative 4x to power negative 3 plus 3x power negative 2. So that is how they differentiate polynomials. Thank you for watching, and please subscribe to my channel, Rowa e-learning platform.